Hello everyone, welcome to our group presentation. We are from Group 2 and today we present to you our project Warships. um, our developer team have 4 members: Hồ Thắng Tiết, Nguyễn Thế Vinh, Tôn Quang Tấn, and me, Ngô Quang Hải. In the work distribution table, you can see that we have a lot of jobs that are equally divided into 4 that including tester, whisper, as well as UI, UX, and frame. Now come to the content part. In our project, the content is divided into 4 parts. The first part is the overview, the second part is diagram, the third part the method, and the final part is the demo. Now come to the overview part. In the overview part, Warship is a Java-based turn-based strategy game inspired by Battleship. Players play ship on a 10x10 grid and take turns launching attacks to sink their opponent's fleet. The game features an interactive UI, dynamic ship displacement, AI opponents, and real-time status updates for an engaging gameplay experience. The objectives of our presentation is about first, demonstrate OOP concept, show how OOP principles are applied in the game. Second, highlight learning, demonstrate the understanding of OOP through the creation and development of the game. And finally, present engaging gameplay, showcase a fun and playable game that effectively utilize OOP principle. So you see that our project create a game that is based on the classic battleship game that was very famous in the 1945. So that is the end of my part. The other part will leave it to my other teammates.
Okay, hello. We move to the use case diagram. The use case diagram for the battleship, you can see that there are 2 actors, that is player and bot, and 2 of them will interact with the system. The player will start the menu, where they can choose to create a new game, or set up ships, or quit the game. When creating a new game, the player process through the setup ships and play ships. Use case to the prepare their fleet. Gameplay alternate turn between the player and the bot through the take turn use case, where each actor selects a target grid to attack using choose target use case. The game continues this cycle until one side fleet is destroyed, while the player can exit the game anytime via the quit game use case. And this diagram provides a clear overview of the system structure and flow. And next we move to the UML class diagram. This will help in a better understanding the relationship and the responsibility between the battleship system. First, you can see the battleship class. That's the response for the acts as the main controller initiates and manages the game. The method is main string. That is entry point of the application where the game is initialized and started. And move to the map class. That is include many attributes such as the map to define the size of the map, and null, nave, aqua, and heat. The symbol represent empty cells, ship, water, and heat. And you can see the map. This is the grid representation of the map. List navy is the list of the ship positions. And the method constructor of the map to initialize the map. And you can see the map random is randomly fill the map with the ships. And clear, you can see clear. This is used to the clear the map. And intersect nave. That is the play a ship in a specified coordinate and verify The vertical is used to validate the vertical placement of the ship. Hit, you can see hit. That is for the register the hit on the maps, and the sunk position. They will check if the ship is sunk. Next is the computer with the attribute like list his track for tracking his position, or random is used to random the number generator for decision making. Hits for track the number of hits, and you can see the direction for the current direction of attack, and also the other attributes. And the method computer map for constructor to initialize the bot. My turn that execute. My turn report that execute the button and return the results. Shoot random with the Boolean type is for shooting randomly on the grid. And we move to the position with the attribute like cost x and cost is for the x coordinates and y coordinates. And you can see the method that is the position is for the constructor to initialize the position with the get. It's like the getter for the coordinates, and the spot for smooth the position based on the input direction, and the equals that is for the compare the position, and for remap it check if the position is valid or not, in the bounds or not, and to string for the convert the position to a string. Direction with the attribute x and y for the initial coordinate. The method is direction to construct and define the direction. Get is in it and get y in to get for the initial values. And you can see the you guys for the Boolean type is for the comparison the direction, and the equals is for the comparing the object, and the report as include the attribute of position his and sunk. His and sunk with the Boolean for indicate the shot his are not sunk are not sunk. With the methods a report is a constructor to initialize a report. Yes is hit is sunk is getter for the position hit status and the sunk status. Set hit and set sunk is also the type of boolean for the setter for hit and sunk status, and to string for convert the report to a string. And this on for the UML diagram.
So moving on to the notable classes, we will talk mainly about two classes, computer class and map class. For our computer class, it is a crucial piece for our single player game, and we control its behavior based on a hit counter. So at hit equals 0, a short random function will be invoked to select a random position on the map, and the short position will be recorded in the last shot. A function map.hit1 will check for a hit or not. If hit, the counter is increased to 1 and check if the ship is sunk using the map.sunk. If sunk, it will update the report with set sunk true and remove the surrounding position using remove counter. This will increase the efficiency of the computer, and the hit and direction will be reset to null. If the ship is not sunk, it will store the first hit position in the primal hit and initialize the possible direction in possibility. Return the status to the report with the short position in his status. So at hit equal 1, a function is called to shoot one of the 4 directions around the primal hit. Record the short position in last shot and check if it a hit or not. If it continue to hit, the counter will increase to 2 and reset the possibility to null. Since at this point we will already have the direction of the ship. So after that, it will handle as the previous case and return the status to report. Next, for hit counter equal or larger than 2, a function is called to continue shooting in the current direction. If the current direction is blocked, a invert direction will be invoked to reverse the direction. So it will continue to record the short position in last shot and check for hit. If hit, increase the hit counter, check if the ship is sunk or not, and handle it as the previous case, and then it will return the status to the report.
Okay, now it's come to the map class. So right here you can see the first one map the will map randomly. Okay, so the purpose of this is populate the game map with a mix of ship ranging size from 1x up to 4x. Right here you can see. This ensure variety in strategic gameplay. Okay, so the function of it is to fill the map with random placement of the ship. Okay, so the implementation is the function iterate through predefined ship size. For each size, it's called insert ship random, a helper function that handles the random placement of a ship on the map. Okay, so what does it do? So it checks for the collision and ensure that the ship fits within the map boundary. Okay, and to the noble feature of this, so the function ensure that all the ships are placed in valid position without overlapping onto each other. And this also ensure that the ship placement are randomly and 2 games cannot be the same. Okay, next we have the check if sunk. So its purpose is to check if all position of ship has been hit. Because there are 1x, 3x, 2x, and 1x, right? So the 1x ship only have to be hit 1, but the 2x and above have to be hit that much about of pixel. Like 2x, we have to hit it twice. 3x, we have to hit it 3 times. So it iterate over the list of positions occupied on the ship. If every position has been marked as hit, the ship is considered as sunk. Okay, so the function then remove the sunk ship from a list of active ship. You will see it in the game later. So now I will show you the demo. Right here, when you click into our game chart, warship.char, you see here loading screen. So now, this is the menu. There's a big map right here, a 10 by 10 grid. And here are the ship type we have, a 4x4, 2 3x3, 3 2x1, and a 1x1. Okay, so there are 2 types, horizontal and vertical. So this is a horizontal ship, and this is a vertical ship. So here's the random function. When you click random, it will generate um, a random position, a random placement for all the ship. Here the reset button, you can clear everything by clicking the reset button. So let's try to play the game. I choose randomly and go for the battle. Okay, so in this battle there are 2 maps. First is player map, and the next one is computer map. So right here, under the map, there will be two boxes. For each person is their list of active ship, which means the ship hasn't been destroyed, or we could say hasn't been sunk. Okay, so player turn is always first. So let's click this. So when you see nothing, that means you hit nothing. And also after your turn, it's computer turn, and here is their target. So they hit nothing too. Okay, let's try to play into some more hit. Yeah, now you see the computer had hit this right here, and because it is 4x1 ship, so it will be count at not yet sunk. So there will be fire gift right here to show it. And when you hit something, the next turn is your. So it choose right here. So it's my turn now. Here, for example, I hit one twice. Okay, so I hit three. So it's a 3x1 ship. See, it's great right here. Okay, my turn again, and I hit again. Okay, so let's talk about the CPU. So when hit equal 1, CPU will choose randomly, but when hit, no, when hit equal 0, it will choose randomly, but when hit equal 1, it will check that if the ship has sunk. If it hasn't sunk, then it will choose the next target in the plus sign. Plus sign right here, you can see it choose from the left, and I will choose from the right. The next one, it may be choose from up or down. Here, I'll show you. Yeah, it should down, and it's not correct. So the last thing is up. Since it's up, it will continue to go straight up until the ship is fully destroyed. Okay, so that's very much of our game. So back to the demo and to the presentation. Okay, so when the game is over, you will see the notification panel pop up, say you are winning or you win the game or lose the game. So here I have lose the game, and say you are defeated. There are two options for you to choose, which is exist and new game. Okay, now that's the end of the demo. Let's go to the conclusion.
So, in conclusion, during our development, we discovered that the software component intertwine with each other as the game environment, narrative, the gameplay mechanics, and some technical issue are all intertwine and have something to do with each other. This force us to adopt to different approach and consider each for each element. It will this also provide our valuable hands-on experience and improve our skill in teamwork and development skill. And that will bring us to the end of our presentation. Thank you for listening.